So
It's a number that makes an equation true.
it is a number, or we'll say numbers, because sometimes we'll have multiple. So we'll go a number or numbers that can be used to replace. What do we use numbers in to replace in an expression or an equation or an inequality? Yep. Variables. To replace a variable or variables to make a statement true. All right? You might have multiple variables. You may just have the variable x. You may just have the variable y. You may have a combination of the two. Potentially, you could have a third variable, a z, an a, a b. But when we're talking about solutions, we're looking for some numbers that can be substituted in place of the variables that will make our statement true. So we'll begin with an equation that you ought to be fairly familiar with. We have y equals 1/2 x plus 4. And we want to complete the table to find solutions. So I have given you one value here. I said the x value is going to equal 0. If I make the x value equivalent to 0, there is only one y value that will continue to make that statement true. Jerry? 4. If I substitute a 0 here, he says a 4 there would make that statement true. Do we agree?
Yeah.
All right.
Yeah.
So 0, 4, or x equals 0, y equals 4, would be one particular solution for this equation. Another one. Let's now say that y has to be the number 12. What is the only x value that would make that statement true? Yes, sir?
16.
16. 1/2 of 16 is 8. 8 plus 4 is 12. So another solution would be 16, 12, or x equals 16, y equals 12. The last one for this. Let's go. X is -20. What is the only y value that would continue to make that statement true? That young man's sitting down. Yes.
-6.
-6. Half of -20 is -10. Add 4 to that is -6. Are there other potential solutions to this equation?
Yes.
How many more? Are we missing 1? Are we missing 2? Are we missing 10? How many more possible solutions would there be? So
An infinite number?
there are an infinite number. There are an infinite number of them. We've listed a couple of them. You could be more creative and choose other numbers besides 0s and 12s and -20s, and you could come up with other number combinations for x and for y that would still make this statement true. Right? You could be here all day doing it. We picked a select few samples of x's and y's that make that statement true. Here's another equation. 2x plus 5y equals 100. Still has two variables, x and y. There are going to be an infinite number of possible solutions to this. We want to try to identify just a couple. If I say x has to equal the number 0, what value must y take in order to make that statement true? Yes? It's got to be 20. Has to be 20 because that would give me 2 times 0 is 0, plus 5 times 20 is 100, 0 plus 100 is 100. What if I now say the y has to be 15? There's only one value that the x can take to make that true. Do you know what it is?
12 and a half.
It is 12 and a half. How did you determine that number?
15 times 5
Is how much?
75.
Good.
And then 100 minus 75.
So if this piece here equaled 75, that there had to equal 25. And what's after 25? 12.5. So we know this works. That gives me a value of 25, a value of 75. Add them together gives me a total of 100. That makes a true statement. Last one, let's swap the 15. Let's put the 15 over here in the x position. So,
2 times 15 is 30, and then if you subtract 30 from 100, it's 70, and then you divide 70 by 5, and that's 14.
it is 14. Good explanation as well. All right. 2 times 15 is 30. 5 times 14 is 70. 30 and 70 gives me a true statement. 30 plus 70 does truly equal 100. Again, we could be doing this for a long time.
I think it's done right. I'm sure.
No, this guy hasn't seen it yet. We could be here all day doing this. We picked a select few. I picked a random number. You were able to find the either y component or the x component that would match with it. Lower half here. What's the difference between these bottom two problems compared to the previous two? Yes, sir.
Well, part one's more equation, and these are inequality.
How can you tell?
Because it says here's an inequality.
It does say here's an inequality. What else would clue you in besides the fact that I actually wrote the word inequality?
The symbols.
The symbols.
Yeah.
There is no longer an equal sign. We have one of the greater than signs, less than signs, greater than or equal to, less than or equal to, some sort of inequality. If I was to read this statement, how would I read this statement using that symbol? Jack?
Y is greater than 1/4 x minus 3.
All right. Y has to be bigger than, which means that my solution set, my possibilities for solutions, becomes even larger. All right. I don't have to find two numbers that work specifically to give me a targeted goal. I have to find two numbers that work to give me a value where one of the values is bigger than some targeted goal or smaller than some targeted goal. It doesn't have to have that same precision. So first example, I want to use the number 0 for x. What's a quarter times x? Subtract 3 from that? Negative 3. Can you tell me a y value that would work here such that my y value would be greater than that value over there, negative 3? What would it be?
0.
0. 0 is bigger than negative 3. Sure is. Could we think of other values that are bigger than negative 3?
Yeah.
I'm sure you could come up with many of them. 0 is one possible solution here. Right? In our previous examples, working with the equation, there was one specific value I had in mind. Now there are many, many values that would fit this particular true statement. Next one says negative 6 for y. I want a value for x such that when I substitute it in, my right side of my inequality will give me a number smaller than negative 6. Anyone get a number that they think would work in this situation? There's an infinite number of them. Yep.
Negative 16.
Negative 16. What's a quarter of negative 16? Negative 4, right? What's negative 4 minus 3? Negative 7. Is negative 7 smaller than negative 6?
Yeah.
All right. Negative 16 works. One possible solution. Many, many others exist. Could have used negative 100 there. Quarter of that's negative 25. Subtract 3 is negative 28. That's much smaller than negative 6. But we were just looking for one number that would make it true. Let's go for this one. I'm going to put a 10 here. What's a quarter of 10?